stick it in. So I know that I'm terrified of Belinda's violence, so I'm going to get on with it. And I'm going to use this. I do wave my hands quite a bit, but I'm nowhere in Gary's class at that, so I actually need one of these. So, oh, but this doesn't have the thing, so this is a picture many of you will be familiar with that was described by the French ecologists in West Africa, first in the 1930s, and they called it Brousse tigrée, or tiger bush. And you have these little strips of very densely vegetated land separated by basically bare or sparsely populated. And they occur all over the world in semi-arid regions, in the Americas, in Australia, and everywhere. And Tongwe and Ludwig in Australia produced a quantified model of this, which is really quite good. And they showed how the water accumulates eventually and then it begins to infiltrate, and there's a positive feedback between infiltration and growth, and so you get these banded landscapes. And then as you build up at the end here, during a drought period, not enough water gets there, so these actually die. And then in the next wet period, this lot erodes and flows down. So these bands actually migrate up slope in little fits and starts slowly. So that model is quite well worked out. And it shows that you need two scales for that to happen. Things function at a landscape scale and then at a local scale and a different local scale. And it's the interaction across that brings up this banded landscape system. Now, Max Rietkirch in the Netherlands studied this, in fact, very nicely and produced a process-based model, very simple, with plants, surface water, rainfall, some runs off, some infiltrates, uptake. And in this model, the key feature was the effect of plants, the positive effect it has on infiltration. And that creates, in fact, a feedback loop. And that feedback loop is critical because, as you will remember, in resilience theory, thresholds are where feedbacks change, where feedbacks cause massive changes. And what this really led to, what Max showed, was that there is, in fact, a bifurcation in the dynamics of these systems whereby you can have two states of those semi-arid systems for the same amount of average rainfall. So below about 1 millimeter a day, it's always bare, no matter what you can do. It's basically desert. And above this level, it's always pretty well vegetated. But in between, you can have a gradation of these banded landscapes, but they can either be in the banded state or bare. And this threshold separates them. And that threshold that gives you these two states of the system is due to that feedback process. And that feedback process there is occurring between scales. And it basically gives you these two functional scales interacting, gives you this banded landscape, one landscape functional scale where it's been reduced to grazing, and then it stays in that state. Okay. Just want to introduce that notion. Now, if you look at, in the same area in the Sahel, which also worked in Queensland, and this was published some time back, if you look at the biophysical gradients and the social gradients in terms of like debt-to-income ratio, there were thresholds identified on both of these gradients. And if you're below this threshold and below that one, the system kind of self-organizes and it tends towards some kind of equilibrium state. The equilibrium state itself will shift around in here depending on rainfall and so forth. But that's the way the system self-organizes and functions. But if you cross either one of those thresholds, if you cross this one, it tends in this direction now instead of tending in that direction. And what that means is that because you're getting less and less grass and grazing, your debt-to-income ratio goes up when you cross this one. If you cross that one, you tend to overgraze to try and reduce your debt-to-income, and you might come down, but more often you go across. And if you do cross both of these, you land up in what they call the doubly defined desertified trap, because it's really hard to get out of. You've now crossed a social and an ecological threshold effect. And what I wanted to do is just put this simple thing in to emphasize the importance of the social ecological linkages and how they interact. In some work that I was doing with colleagues in Australia, we identified for the Golden Broken catchment 10 thresholds that were interacting at 3 scales, from the landscape farm scale to landscape catchment up to the state or Victorian nation scale, in the social, the economic, and the biophysical domains. I'm not going to go into all of these, but each of these were thresholds that the stakeholders had identified with us as scientists, and we modeled some and quantified them, and it's pretty much agreed. And the point is that those thresholds interact. If you cross one threshold, it can lead to an increased likelihood of crossing another one, or sometimes a decreased likelihood of crossing another one. And if you look at that system, then it's basically driven by shocks. Price ones, market, climate, diseases, or whatever. And depending on the kind of shock, one or more of these will be more or less likely to be crossed. Now, the value of this was that those people thought this was incredibly helpful to them in that catchment, because for the first time they envisaged their region like that. Instead of just variables that were producing food and stuff, they started to think of them as threshold effects with feedbacks amongst them, driven by these shocks. And that's a resilience perspective of how to try and imagine a system. And the thing that emerges is that you cannot understand or manage a system by focusing on one scale. And that's a statement that I challenge you to refute. You need at least 3 scales. The focal scale of interest, the one why people are there and what they're really interested in. The farmer will be the farm scale. The state person will be their scale. And you need at least 1 below and 1 above. And usually you need about 5 scales interacting to really understand the dynamics of the system at any one scale. The biggest single fault that people make is to focus on the scale they're interested in and try and understand everything at that scale. Increasing resilience at one scale, or pursuing efficiency at one scale, which is what often happens, can lead to reduction of resilience at other scales. Often a trade-off. You make things resilient in this way, they become less resilient at another scale. The Murray-Darling Basin is an example of maintaining resilience at one scale requiring transformational change at another. In Australia, there is simply not enough water to keep everybody in the Murray-Darling Basin system with its mini irrigation settlements doing what they're doing now. For the Murray-Darling Basin to remain as a resilient agricultural, social-ecological system providing human well-being, some parts of it have to transform. And those bits that have to transform are opposing it as strongly as they can. And of course, that's the problem that you face in development. But that feature is something that needs to be recognized. So I would make a proposition that maintaining resilience of many nations may actually require transformational change in the global economic system. So this is kind of transforming at the lower scale to make the big scale resilient. And I'm saying that also you might have to transform at the global scale to make the national scales and sub-global scales resilient. Transformability is difficult, and people hate transformational change. But there are 3 components to it. This first one is getting past the state of denial. That's actually the hardest one. We don't really have to transform. The second one is having options and creating options for change and transformation. And that emerges from these things. And the third one is having the capacity to change. And that comes from 3 things. One is all the capitals, whether you've got enough financial capital and social capital and natural capital to allow you to do it. It comes from reducing the resilience of the existing state. So resilience is neither good or bad, and there are many resilient bad states, and you've got to reduce that. And the third one is the higher scale support. And I've emphasized governance here because in all the studies that we've been doing and involved in, governance is the thing that's the problem. This is what emerged out of a work on the Walcool Shire in the Lower Murray, where we were looking at the focal scale, which is that shire, and these are the 3 things that you need. Okay, getting beyond the state of denial. Well, most of them hadn't had water applied for 3 years because of the drought. They were sort of got beyond the state of denial. The second thing was developing options for change. And this was done largely at this scale. People were trying different ways and experiments to change from irrigation to some other form of farming or whatever. The third are these higher scale interactions, enhancing the capacity for that transformation to occur. And what they started to do was looking at positive interactions and negative interactions at these higher scales, and both were there. In some cases, the interactions were preventing them from transforming. In others, there was some help. And they also came up with ones that were missing. And they needed to put linkages in there to enable transformational change. And what I'm wanting to say is that building resilience at this scale, at the focal scale, can require transformational changes at this scale or at that lower scale. And the thing that emerged out of that effort in different places was that all too often, higher scale support is actually in the form of help not to change, instead of help to change. It's not that money wasn't available to help them, but it was circumscribed in such a way that it could only allow them to continue what they were doing instead of transforming. I'll come back to that. So this is the question that comes up. Where is there a need to build resilience? And where is there a need for transformational change? And both of those at different scales need to be considered as paired questions for any regional management or development program. Continue with the rangeland theme. Marco Janssen spent time with us and he developed a really nice agent-based model which had two kinds of rangelands in it, and it was a very good model. It was based on excellent data and it had a good sort of dynamic model underneath it. And you had a social one about people, pastoralists, and these are the kinds of decision levels they made about things and so forth. And the third part was this government regulator regional scale part. We needed those three models to run this agent-based model. The regulator in this thing was, we eventually assigned three kinds: a conservation regulator, a stability one, and a free market regulator. These happen to coincide with the three main political parties in Australia. And we then ran the model under different kinds of regulations, sometimes swapping it for 50 years or 20 years at a time, or 10 or whatever, all sorts of combinations, and came up with some very interesting outcomes. And I'm not going to go through them because the point that I want to make with this model, and we used it and took it around and discussed it with all sorts of state agencies and everything, was the weakness of the model. The weakness of that model was that we could not get a dynamic model of the whole system because we couldn't model this. These linkages were very powerful. And in fact, what happened was that it was this one. The effect of pastoralists, the condition of the pastoralists to the government and how they react to that to make a change back. It just wasn't a two-way process. In fact, what we found was that was very weak. And the regulator was the model of federal government, state government, industries, and political parties all interacting. And that is what actually determines the fate of the pastoralist. And often, it's got nothing to do with the state of the pastoralist. One-size-fits-all state regulations are making decisions here because the political eye is on something over there. And in fact, this thing we could not model. And that was why we felt it was a failure in the sense of not being able to do a full agent-based model. It comes back to this incredible importance of how do you get a handle of governance and how do you model that stuff or understand it well enough in a research context so that you can include it into the sorts of things we do. And I don't have an answer for that. I call it the P-squared problem, the power times politics problem. And how do we encapsulate and understand that lot in a way that enables us to apply resilience thinking into the field. Okay, any social-ecological system then at any scale can be envisaged as these controlling feedbacks. Can we identify the key feedbacks that are keeping it on an unwanted trajectory, or that are missing or too weak to move it off that trajectory, or are important existing feedbacks that we actually need to maintain and do something about? If we could think of feedbacks, we'd be in a far stronger position because they are what planning and management need to focus on. So think feedbacks. And examples of controlling feedbacks in the energy system, those that reinforce fossil fuels. In forestry and agriculture, ignoring costs to other ecosystem services, missing feedbacks. The polluter pays is a feedback from doing what you're doing and to dumping stuff in a river. If you pay for that, there's a positive feedback that stops you dumping. So that's a feedback that you need to introduce if it's not there. Subsidies, bailouts, etc., the exceptional circumstances funding are in fact as a misapplied version of a feedback. So current global governance is largely failing because national self-interest, the silo structure of international agencies, they suppress and mask secondary global scale feedback effects. And that's why we're stuck on these trajectories that Gary was describing. In global cooperation, self-interest has negative effects to regional and national scales, and these are what I described earlier, the negative feedback effect from the bottom up, and these are negative feedback effects from the top down in terms of resilience. And how do we cope with that? How do scientists get this message through and deal with stakeholders and governments around it? The wrong one, but never mind. I'm going to switch over that and go to this, because these are the cross-scale domain connections that we've got to worry about. Climate, water, energy, and food all interacting with each other. It's those feedbacks across scales and domains that will determine the trajectory of the Anthropocene, the thought, which I hope might come into here, and following on Gary's. There is now a group known as the Resilience Action Initiative, formed by 10 of the world's biggest companies, led by Shell, but it includes Dow Chemical and Rio Tinto and Swiss Re and others like that. And these companies are saying that for their own companies to remain resilient and survive, the environments in which they're embedded have to be resilient. And so they're doing their own scenario analyses of saying we actually have to do something about making the whole world more resilient, or we're going to go under as well. That's the first positive thing that I've come across. And it's a lot more, there's no website for this because they don't want to boast about it yet or anything. They're waiting until they can get this thing up and running more. And it's a lot more productive working with that than with governments. So getting governance right is going to be working with industries, business leaders to whom governments are actually listening. And I think the whole problem is, will we be able to do it in time? You know, are we actually going to run out of time before these things push us over the boundaries that Gary was saying I might disagree with him on? And most of them I do, but it depends which boundaries we cross as to whether we'll have time to get back from some of them. And I'm afraid to me that's a question that I'm not confident enough to predict. I know some dismal people are saying that it's too late, we're gone, and it's all over. I don't know, but I think if we can focus on these interactions, this is this looming nexus between water, energy, and food that RAI is focusing on that I think we need to address. So thank you very much.